And I tell you the truth, that if you should keep silent, even the rocks would cry out. Those are the words of Yeshua of Nazareth, as recorded in the Gospel of Luke, chapter 19. I'm the Great Baldini, and these are Unintended Consequences. Good morning, good afternoon, good evening, good night, wherever you're joining us from. We're glad you're here for episode 12 of Unintended Consequences, where the music is original, the content is organic, and the possibilities are endless. Stay with us for more Unintended Consequences. Well, alrighty then. Hey, good morning, everybody. Hopefully everything is running smooth. Tried out some new stuff today, and I know better than to do that. I say that every week, don't I? Hey, Bob. And everybody, we got Rose 777, Bob from Globebusters, Sue Finelli, and Green Queen. Nachakita, we got the whole crew here this morning. And I see that Nachakita, you just got through with a little round with Red Fox, my friend, who just, he was on just a couple of weeks ago. So it's great to have you guys here. We'll do just a quick bit of housekeeping this morning, and then we'll introduce our special guest, who is a little under the weather today, as some of us are. So in any case, I wanted to say, again, thanks to everybody, not only for showing up, but we've got some more contributions for the computer fund. I wanted to thank people for that, and let you know, again, you can reach me in a variety of ways. Send me an email, unintended.consequences3@gmail.com. You can send a note via snail mail to P.O. Box 2248, Linwood, Lynnwood, Washington, 98036. And I'll put some stuff up at the end if you want to make some contributions to PayPal, well, whatever. Trying to reach in your pocket. Just we had some people send some stuff and send personally a great couple of notes here. One of them I want to say thanks. La Sung Chan, I got your stuff, and I'm checking all that out. And I got a let's see, where is this at? Is this what I want? That? No. I guess I didn't find it. Oh, there we go. Somebody sent me this book. It showed up in my mailbox, and I was like, what did I order from Amazon? I don't remember. And then I opened it up, and it was this awesome book. Thank you very much to who sent me that. It's a coloring book. You're fucking awesome. So you are awesome to whomever sent that to me. So I really appreciate that. It's very cool. All right. So today, again, without belaboring it too much, so a couple, 3-4 weeks back, I guess, I was a guest on Iron Realm Media, and was the first time that I got a chance to speak with Cami Knodel. And she's been a long-time member of the community here and all over the place. And we just had a terrific time. I think this is probably the longest I've spent on any stream. It went over 3 hours, and we just had so much to talk about. Well, we just thought we'd do it again. And specifically, we were intrigued. Offline, we were talking a little bit about conversation that I had with Wayne McCroy, Jason Lindgren, and RV. Was RV in that? I can't. It's been a blur. I don't remember now. We were talking about consciousness and panpsychism, the concept that everything in the universe has a certain level of sentience to it by virtue of animus. And so one of the people who is best educated on geology and gemology in this community is Cami Knodel. So welcome, Cami. Are you still with me? I hope so.
I am still with you. Good morning, everybody. It's been a rocky morning. Is that penny for you or?
No, it's good. You're still, yeah. Even under the weather, you still got it. As as our friend from Happy Days used to say, Ralph would say, I still got it. So I noted, I was listening to a stream that you were on yesterday, and I noted that did I hear correctly that with the sale of the house, you're going to North Carolina? Is that what I heard?
We are going to either North Carolina, very the southern part of it, or quite probably northern South Carolina. So
The
somewhere, I think
Carolinas.
the Carolinas is right. So
Wow.
somewhere between like Charlotte and Greenville or in and about that area.
Wow. So my next question was now then seeing that Brian Stavely was there, and of course Ted Summer moved out there, but for good reason. Is Karen B starting a cult? Is that what's going on? Are you guys
Um,
got a commune going? Is that the thing?
You are so funny because as a joke I put in because I've been looking at properties. One of the properties that came up for $299,000 in that area was a church compound that had a full-blown church and it had a rectory and it had a school
Oh
and
wow.
and it had a little, it had a house for a complete compound. It had 4.5 acres and it's like, oh my gosh, a little bit too Waco-ish for me, but
Well,
isn't that funny?
Okay, so what's really funny, no one, well, I haven't spoken about this, but I did once with Joe Ray. I don't know if Joe is in the chat this morning, but he's the guy that I did a lot of songwriting with back in the day, and that's some of the music that you hear. He and our drummer Jim, who's no longer with us, but we for almost a year lived in a place in Azle, Texas. That was a compound. It used to be a church. It had a little rectory house there. So I took that one. I was the oldest, so I took that and I called it the David Koresh Suite because it was exactly at the time. In fact, I was in that building when I watched Waco burn down live on TV. But yes, we called it the our own little Branch Davidian compound. It was on an acre. It had been a school and a church. It was really cool for us. I mean, we had a band set up in there, and so we had a studio going and everything. That's very very interesting. So yeah, everybody's looking for new spaces.
New
Well,
spaces. Yeah, it was interesting. I was in Israel once and I stayed at a kibbutz, and it was actually one of the most beautiful places I've ever stayed in my life with the all of the artists that stayed on land and the amazing landscaping and gathering around for music and singing at nights. And I did that for I think like 4 days in a kibbutz, and I don't know if it was really such a bad thing. I guess I did it too short of a time for it to be anything but magical.
yeah,
But
everybody
yeah,
seems
just
normal till you get to know them, right?
that's right.
I know that's for sure. So, if you're, I know that we're going to play a video that you introduced me to, dealing with rocks and crystals, and we certainly want to get into that as a specific topic. But if you're able, if you're up for it, I'm sure this is part of the thing that I always like to cover is if you can walk us through a little bit of your own awakening process and sort of when and how that happened.
Um, well, that's an interesting awakening to flat Earth or awakening in general,
I think
or
in general, I mean, unless flat Earth was your first kind
Mhm.
of wake up call to like, hey, they're not telling us everything. It wasn't for me, but for some people, it was their big one. So, yeah, yeah. So,
uh,
like, where did it start for you?
that's going to be a good one. As many people in the audience know, I am married to Bob from Globebusters. We'll be married 18 years next month, or
Awesome.
actually in a few days, less than a month away. Um, And we have always, like living with him, we've looked at the pole shifts, we've looked at Nibiru, we looked at,
All the good ones, yeah.
alternative.
All the good ones, yeah.
Even before then, I was looking into vaccines. I'm trying to remember when we weren't questioning everything. I mean, I'm really trying to think back on when we weren't questioning everything. I know 9/11, Bob jumped on like right away before
Hmm.
anybody, like one of the very first he jumped on, and I was at the time going through a lot with work and personal and different things like that. And it really that one pissed me off because it's like, no, we didn't blow up our own buildings, and that one I did not buy into right away, and it took him a little. I think it took him the find the playing game with me, and it's like, okay, I can't.
Right.
Let's start looking at this and looking at it as a whole, and it's really there. So I don't know if, um, I mean, I'll look into, or we've looked into everything.
And so
And
was this were you both kind of I'd say conspiratorial minded or open to these things prior to meeting? Was that a point of tangency for you when you met and got together? Was that something you had in common, or did you kind of migrate toward that together?
No, I think both of us separately, him more than me. I don't even know what it's been a long, long time. It's been a long, long time.
Sure, no, I
But we
understand.
both had different curiosities, and we're both, I think, overly curious people. And actually, I think I'm an overly curious person, and I think he's an overly skeptical person. And when you put the two together,
You go a long way down the rabbit hole.
you
That's
go
for
a
sure.
long, long, long.
Absolutely. Okay, so clearly not a new thing for you. Yeah, I mean, for myself, I think I always asked a lot of difficult questions, even in school, and got into quite a bit of trouble for it.
Exactly.
I know it was for me in would be in the mid 1980s. I was already even at that point familiar with. Masonic rituals, that sort of stuff, and a lot of the occult sort of thing. So my dad gave me a copy of a book called The Unseen Hand, and conspiratorial look at history. And that kind of he it's by Epps or Epperson, something like that. I'll have to look it up. But yeah, it covered most of the basics, and even covering the New World Order, something that didn't get really publicly spoken about until George Bush Sr. Mentioned it in his speech on September 11th, 1990. Right, and so I was like, oh boy. So yeah, I've always had a skeptical eye and kind of had a sense of things, and I would say it took me at least a couple, 3-4 weeks maybe or so, to start really skeptically looking at 9/11. But it was no surprise to find out. That was an issue. Even back at the Oklahoma City bombing, I knew right away because I think I've expressed this before as well that I was kind of working in media at the time that Waco happened, and so I had some exposure to what was happening there. So yeah, never been too trusting of our lovely government. Although I didn't come to a place of realizing it was all, wrestling with different outfits until somewhat later. So. Okay, so you had looked into from everything from Nibiru to Hollow Earth to, you name it, pole shifts. I mean, I can go through the list as well. Go, yeah, I went through all those. And so when did you begin looking at cosmology and cosmogony?
That, Bob, is very, very early on. It was like Jaron had just put out one of his first videos, and I think Eric Dubay was out there in Mouth Powerland. But this would have been the end of 2014, beginning of 2015, I think.
Exactly the same time I did, yeah. Right. Just I think mid-October of 2014 is when I first started looking into it, and my wife was none too pleased about it.
Yeah, I was none too pleased about it, to be honest. To be perfectly honest, I was none too pleased. And yeah, my husband ran it by me, and he was like, "No, here, you have to sit and watch these videos." And from, how many years of prior living with him, I know that you have to watch these videos means that I have to sit down and watch all of these videos.
That's not just like, okay, honey, I'll look at it later. It's like, no, you sit down right now. Yeah.
You have to sit there right now, and it's like, no, we're not playing this game. I'm knocking this one right out of the water right here, right now. I got a globe. I sat there and thought, people travel, packages travel, shit travels around. The measurements would not work the same. Things would not be able to travel the same. So I looked up itineraries. I looked up laden, packages. I love doing it through packaging and through business because I have such good laden documents on it. And I took a string and a globe, and I just started doing some things to knock it right out of the water. And all of a sudden, I started getting into weight. There are no, because back there are no, there is nothing.
Yep. I
And
think we all had that moment of like, oh God, it
so
can't
that
be. Oh man.
it can't be, but that was like super irritating. And the more I looked in, and 3 or 4 hours for me, again, that night, that's like to get in and to look at that many stupid packages and to try to find that one click and then different ways. Um, and then again, every time that we would throw up a why it can't be, we would talk about like, well, different possible resolutions that would work on a flat earth. And it's like, for every it can't be, it really doesn't work on the globe. And yet there's 10 possibilities on how it could work on the flat earth. And I don't know, the rabbit hole started really getting deep.
Yeah, I know. I spent about 10 days of sleepless nights, right? And I came from the physics perspective and having a background in physics, and I started looking at everything I would, I, of course, again, like many people, tried to debunk it, and that didn't work very well. And then I tried to come at it from proving, the heliocentric model, and that was upsetting.
Exactly. Every angle you take on it, it shuts you down.
Yeah.
And yet you know in your mind how stupid flat Earth is. I mean, you've been programmed. You just, I mean, you're repulsed away from the idea through the programming because
Initially I
there's
was.
yeah, there's
But
nothing smarter than a rocket scientist and nobody dumber than a flat earther, and it's hard to like want to go there. Oh,
yeah,
I want to be called the dumbest thing.
yeah, exactly. Well, I mean, I wasn't as concerned about that. I didn't have any. Again, I wasn't ready to run out and tell everybody about it, but I just wanted to know, right? And so once I kind of tried to prove it, and what I really got irritated was that I'd never stopped to question it, and that how many things were told us as though they were factual, when not only is it flimsy, but many of them are just they alter the data or turn it upside down. So it's like, oh God, here we go. All right. And then I finally
Yeah.
had to come from a place of going, okay, I'm going to do this the same way that I had done with Scripture way back in the day. Is go, I'm just going to go tabula rasa here, right? Just like I'm not going to try to prove or disprove anything. I'm just going to look at the evidence and go, what does the evidence indicate? And well, you know what happens after that. Yeah, there's nowhere to go beyond that, other than where I land now is to go. What I say is I'm a geometric agnostic. I don't know. I mean, I can't prove it. I can't. There are certain things I feel like I can't make positive claims about. But when I use abductive reasoning and use a combination of inductive and deductive reasoning, I got no place else to go. It presents itself as flat and motionless, and all the evidence seems to point to that. So that's I can prove what it's not.
Yeah.
Right. So,
Yeah, I had an experience. I wonder how many other people had the experience in flat earth that, when you die, your whole life is supposed to flash before your eyes or that. But in my dreams with this, I have flashing between my eyes, and it still happens like all of these times, like a teacher in fifth grade that when talking this said, well, no, the ancients really weren't so dumb, because if you look around in that, there would be no reason not to assume the earth was flat, and everybody laughed. No, we know it's a globe. But little moments like throughout time where it was really put out in front of you. I have flashbacks of those moments now that like I would have never known were even in my mind, and they're coming back to me now saying like, yeah, it was there all along.
yeah, I
So
had moments, and I think I can remember, and I think it was probably second grade, where I had questions about that, right? And they treat it like, well, see, we're smarter than those people, right? So they were so
yes.
dumb they thought it was flat, and so then they get you to this. It's again sort of the Dunning-Kruger effect, right? Where they go, see, now you know the secret. You're smarter than those guys because they were fooled by what they saw, but we're not fooled, right? So now you're smart, and that's immediately it seems to sink in with everybody. So by the time you get even to middle school, they pounded that one pretty well home, that anybody who thinks otherwise is dumb, right?
Right. And the
And
moon and phases, especially, that one really, the way that like my mind used to sit there, they would teach it. My mind used to make, because my mind's very, very visual. It draws pictures for everything. And it would draw the pictures, and it could never, ever draw the pictures on the way that the moon and the sun and that were rotating. And when I say it wouldn't draw it no matter how much I tried. I mean, my mind it makes visual. I thought everybody's minds worked that way. Now I find out some people's do, some people's don't. They're hybrids. But my mind, like, seriously drew, and I spent so much effort trying to make that visual go in motion in my brain on how it worked on the globe side, just because I was so fascinated with space, and I was so disappointed in myself for being too stupid to get it. And no, I was.
I want to just give you a big hug now and go, oh, Cami, I know, right?
I know.
I know.
But I mean, it really, really felt like that. And
because there's always
I think
yeah,
that's part of their
right?
mad. There's always that yeah, but and everything, and it's like they really do make you think you're too stupid to get it, and then you think back, and it's like, well, wait, no, I'm usually a very good visually, spatially person. It's like that's what they're telling me. I'm too stupid to get. I'm stupid in a lot of areas, but that's my forte. I mean, or that's where I shine, and they're telling me where I shine is where I'm too stupid to get it.
Yeah,
And
no, I
I think
agree
everybody
that.
has those areas in it, so
Yep,
it's
and
just
they always do that. That's one of the first places it goes. You just don't understand, right? And that's one where they kind of can't catch me, right? Because I mean, it was like I said, for me, it was physics that was the first. In fact, the very first thing I saw was a YouTube suggested a video, said flat Earth, and I was like, what? And but it was the dog cam video of high altitude balloon footage, and the first thing I noticed was the specular highlight, and I went, what? That's not possible.
That's not possible. That can't work. I know all of the visuals catch me everywhere. We're joking. I have Bob in the chat. And the secret to a very interesting marriage after all of these years, you have, like in the extremes of personalities, put somebody together that's super visual, but the right words don't pop into her mouth. In other words, I see things, I just want to ESP them to people.
Yes.
And I blow up the words all, I'll use the wrong words all of the time. Now put that person together with somebody that's not visual at all, but everything is literal. And what you say, the word.
I've noticed that Bob is an engineer, man. He definitely communicates in engineer. I know. I've worked with engineers for a very long time.
The right word matters, damn it. And it's like, but no, don't you see?
But sometimes literal is funny, right? Where it's like the old joke about the wife who tells her husband, the engineer, go to the store and get bread, and if they have milk, get two, right? And so he comes back with 2 loaves of bread. And she's like, "What are you doing? Where's the milk?" And he's like, "Well,
you said they had milk. There's milk at the store. Bob and I have these arguments all of the time.
Yes.
And I can tell you on our arguments at the house, he is generally 99.999% of the time literally right. I don't know about the other right, but on the rights and the wrongs, he will have the words right. And I definitely I don't know. It's so fun how people's brains work so differently, and yet they teach us, how like all the same we are, or again follow.
Or that we're a machine, right? That's the big one, right? Is that it's material and we're a machine with and the software hardware connection, but that it's electrochemical, and everything that you experience is simply a result of it's just a side effect of the way just a little electrical impulses in your brain. And again, that's one of the things that wanted to really talk through on that topic of consciousness, is because that's the first and biggest problem that led to scientific discovery at all, was this difficulty with consciousness. What make it? What make that? It is fascinating, to be sure, and of course we can't describe any of it, even and especially dreaming. That's a really difficult one. So yeah, it's an interesting thing for sure. And of course, I have always, or more recently, long said, how about that? The secret to a happy marriage is separate bathrooms, but. But no,
that's never a bad idea. Yeah,
but no, my wife and I, we have different ways of approaching things as well, and we don't always agree on things, but we don't argue about the things we disagree on, right? It's she's come to know that I have my reasons for seeing it, and she has her reasons for seeing it, and that to me it doesn't mean that necessarily it's wrong. It's just I don't experience it that way, and I don't see it that way, right? So that doesn't mean that I attack her for believe, or you're wrong. That's just I have learned through experience that that's not necessarily true. We have different perspectives on things. So we get along fabulously, and we really like each other. So there's a big positive there. It does help to like your spouse. That's certainly a good one, and learn to communicate. So, all right. So you, with some trepidation, you jumped on board the flat Earth train, and then you became, part of FE Core. I know that you're an active part of that. So. Tell me about, here's, of course, we want to get more into this. So tell me about your background with geology, gemology, and rock hounding, because it's something that I was interested in as a child, and even got a rock polishing set, but it was too much. I guess I had too much ADD going on. It was just too long term a process, and I was too interested in too many things, and so I kind of set it aside. Later, wishing that I hadn't, because I've been exposed to some things since that are fascinating. So this is where I'd like to kind of pick your brain and have you kind of walk us through some of that.
Okay, as a rock hound and a rock lover, and that I was born. I was born a rock lover. I was that child that always picked up the shiny rocks, and to this day, when we do the laundry or things, like I found a jacket that was sitting in the garage underneath things, and it had the outer pockets, the inside pockets, all of the pockets filled with rocks. Ask Karen B. Anybody look at her house now? I'm dangerous to have around with rocks. They cry out to me. They call. They say, "Pick me up."
Nice.
As a professional going into life, what a happier life, though I did not like the business side of it at all. What a happier life than I went into the jewelry business, and I was a gemologist. So my duties would be like on the business end. People bring in things. Of course, there's people die, there's divorces, you find things on the street, and what is this pretty rock? Somebody has to be able to look at it, test it, determine what the rock is, and assign a value.
Mm-hmm. Identify it. Yeah.
That was me. So it put me in a position with, along with the legal paperwork and things like that, it put me in a position where I got to play with rocks every day of my life. Play with equipment, check everything for fluorescence, refractive index, polarity, all of the nerd fun stuff that makes my heart sing. If I could have done that part of the job all day and not dealt with the politics, my life would have been so blessed. The jewelry industry and the diamond industry is dirty. Yeah. And so it's a double-edged sword to being a diamond buyer. And the other, they would have I was their operations manager, and I was there for 30 years. Also, title would be diamond buyer and inventory control and things like that. But, the appraisals, again, the gemology was my passion, separating things. What I learned through it and what I knew instinctively is rocks grow. I mean, they tell you, yeah, the earth grew and it formed these rocks, and that all happened millions of years ago. But rocks grow, and they don't grow at all like they are described to you, or the way that they intuitively tell you to think, and the way that they sell it in movies. Yep. And the way that they carbon date, and that's not what's happening at all. And again, they are growing at all times. They've never stopped growing. They're like people, though. Once they grow up, I'm not saying that your rocks out there are all still growing and getting bigger, and you can go out and measure your rock getting bigger. That's not what I'm saying at all. Just like when you're growing up, you quit growing. They grow until they're grown up, and they quit growing. But they are growing constantly all around you. I take people out to riverbanks. You can take a rock and hit like the roots of trees along the banks and find where some of them are already turning into stone and fossilized, where the elements are forming, where sandstone is conglomerating and coming together. People don't understand at all the concept of how they grow, and how, people are taught that if you take a dime, or if you take a piece of coal and you squeeze it hard enough,
with under heat and pressure, it becomes a diamond, right?
It becomes a diamond. Or that diamonds take millions of years to form. Right. All of this stuff is hogwash. That would be like taking it in. I'm just giving you from a reality laboratory analysis and what we recreate. And that diamonds grow like other crystals, and they grow fairly rapidly if the conditions are right. Mm-hmm. The more perfect the conditions, the purer the crystal, the longer those conditions hold, the bigger that crystal can grow if you have enough stuff available. So if you had a volcano that went and it cools quickly, you have your lava flows, which are very unorganized, right?
Right.
If those elements have time to organize and it stays heated and added long enough, and that you'll find around all around volcanoes and that, or that you get those basalt pillars. So when you think about the Great Causeway and all those fabulous basalt pillars, those are those elements having time to crystallize and organize. It's happened. It's though it didn't happen and is over. It's happening all around you all of the time. It's a cycle, much like the grass grows and dies, crushes,
Now,
dissolves.
different rocks grow differently, right? They're not all crystals, though, right?
No, they're all everything solid is crystal. And that's something too. Again, you haven't. Let's go back to even. I'm going to finish the diamond and take you
Yep.
onto
Okay.
that one.
Because
And this is
I
going
do
to
have
explain.
some specific questions, right? So,
Good,
yep.
and we're going to give you very specific
Good.
answers. So saying that diamond is like a crushed piece of coal would be like saying, you know how quickly a cottonwood grows and how it springs up. I have one in my backyard.
Yep.
It's like very soft wood. It grows very fast, or bamboo. Okay. You know how slow like an ironwood grows.
Yep.
It takes forever to grow, and it's very, very hardwood, and it's very, very dense. And it took much more years. It grew much solid. It would be like saying, guess what? You can squeeze that cottonwood. If you squeeze it hard enough and squeeze that lattice, you're going to squeeze it into an ironwood tree. I mean, that's how ridiculous the idea of squeezing a lattice structure, or taking it would be like saying, I'm going to take a group of Tinker Toys and I'm going to collapse it into a finer grid line and not.
Right. No,
You know what I mean?
Yeah. No, I get you. Yeah. I'm gonna. Yeah.
Okay.
Yep. No, I'm with you. I'm gonna change the structure of it, the lattice structure. Right.
Right.
It can't be
It's
done.
how tightly it grew. It's how tightly it grew when it grew. You can't squeeze it and make it tighter. That's crazy. What was your question before? Because I
Well,
wanted to.
okay, so specifically having to do with granite, and I know this
Okay. Oh,
specific thing about granite is that they're using a particular means, which it's a little bit technical, but it's basically resonance ionization spectroscopy. But basically, you can find radioisotopic halos for like iridium 192, which has a half-life of less than a tenth of a second.
right.
So that would at least indicate, right, or suggest that it instantly came into being. It formed instantly. It's not over time, right? So because that halo is there, and because the half-life is so short, and you see these, radioisotopic halos that it can't be there as part of the crystalline structure as a long-term thing, right? Now, I can certainly see that different parts could form over time, like the process could occur sequentially. But
Epigenic or.
yeah, something like that, because it's basically, when you're looking through alpha spectroscopy, again, you can see these halos there, right? That gets the impression of it gets left in there. So that's kind of I guess the question that I had is, it seems to me as though, one of the disprovings of the geologic record is that, as what we're told, is in part this like iridium 192 with such a short half-life, right? So I don't know. Maybe you can again speak to that. I don't know, right?
That
These are things I don't know. I just kind of
that
look into
one,
them.
yeah. That one I'd like to look into. I'm very familiar with iridium. It's one of the noble metals. I have not looked into what you're saying the reaction is, and I would like to I would like to address this question at a later time, because I
Sure.
would like to give it some more study. I do think that this movie that we're going to show, this is this movie is from 1958, and what it tells me is it tells me that they understood exactly how everything works, and that they quit teaching it because it doesn't go along with the story, is what this movie tells me. Because this movie is so well done. It is a army movie. It's an instruction on crystals, on how they grow and how they work, and it's by an MIT professor. And he does such a good job explaining again how everything solid you see is crystalline, except for when I say everything, I should say almost everything. If it's completely unorganized, like a glass or a lava, it's not. But metals, when you see metal, it's crystalline. Woods, of course, are not. They're organic.
Okay, but
But
those would be minerals. So
yeah, all of your
organic materials would not be like
yeah,
human
like
cell
amber,
structure wouldn't be
right?
crystalline. Okay, got
Amber, amber, which is a resin, would not be.
okay.
You're
Yep,
going to
I
have
got
a
you.
pearl.
Yep,
You're going to have weird exceptions. So when I
sure.
say everything, but all of your metals, all of your solids, and what we build things out of. Again, we take it. I think without further ado, I think we can like watch this. I think
Okay,
people
yeah,
will be fascinated and learn, and then we can have questions
sure.
afterward
Because
because it says
I
so
got
much.
a great. In fact, maybe I'll just tell it. Like, if you don't mind, I'll tell this as a brief story. And this is one of the things that got me really fascinated and interested in this. Is that a number of years ago? It's been actually a very long time ago now. I was, managing a record label and touring with some of the bands, and one of the bands was booked at a music festival in Tulsa, Oklahoma. And because I was going there, somebody gave me a piece of what was described as petrified dinosaur poop. Well, it was certainly petrified poop of some kind. It had a very distinctive shape. It looked like a very big cow pie, basically, with a little, ice cream tip at the end. But it turned into rock. And so I was to deliver this to a rock museum in Tulsa on the Sunday afterwards. And it was closed, but I had agreed to meet this guy there, and he was an elder guy, octogenarian, and he asked if I wanted the tour. And I said, yeah, sure. And he had the little rock museum there, and as he started going through and describing it, I fell in love right away with his passion, right? He certainly was like really into something I hadn't really given much thought to for the years prior, other than, like I said, when I was a kid. And as he was going through, ultimately, he was showing me a variety of different, different rock formations, and expressing this stuff. And again, he wandered very far off what the the current mainstream narrative is, and he indicated again the growth of the crystals, that sort of thing, and also he expressed, and as we got to the end, it was very hard to disprove what he was saying. That he felt as if by these indications, they were rocks that again that are self-illuminating, right?
Fluorescent, yes,
Yep, that are
naturally fluorescent.
fluorescent. Yep, some that are radioactive in terms of
Yes,
and they actually put out frequencies, and sometimes
yes,
they will alter those frequencies based on what they're in proximity to, including
yes. They interact.
biological organisms, right? So if you walk
Yes,
up
they
to
interact.
it will change its frequency, what it's putting out, and
Yes,
so
it will.
yeah, and so he pointed out he's like
He's right.
he thinks they're sentient, right? That they are a kind of life form that we just don't understand, and it's at such a slower geologic pace, right? That
It's not as slow as he thinks or as they teach you it is. Everything putrefies or petrifies. If it petrifies, things turn into fossil in 2 to 10 years in nature, and when your conditions are right. And if not, when they dissolve and petrify, then they make the elements that will grow rocks in that. The
got it.
timeline is so far off. In laboratory, we can fossilize things in 2 to 10 days in laboratory. Their timeline is a joke. That's why there's so many impossible fossils out
No,
there
I
that
got
people
you.
are finding.
No, I get that part for sure. And like I said, I was fascinated when he got to the end. I was like, okay, I'm in. Right, with this idea that they are sentient to some degree and they interact and they show a kind of intelligence, which I found absolutely fascinating. We're going to play this video, and it is about 24 minutes long. But I've previewed part of it. I think we won't get a copyright strike because it's from the 50s. Alan Holden, 1958, and we will show this video. And do you
Yeah,
have any?
this is commentary and fair use. And this, I think, after people see how crystals grow and really understand how they grow, and they will understand a little bit after here, it gives you a great basis to really understand the sentient angle that you're looking for.
Cool. And is there any other thing that you wanted to say as we set it up, or?
Um, my brain's not working this morning, no, but thank you.
Okay, fair enough.
I suppose most of you have seen a crystal at one time or another, probably in a natural history museum or in a chemical bottle. Here's an unusually big crystal, dug out of a clay pit in Brazil. Here's a smaller one, broken from the side of a cleft in the rock in Arkansas. But crystals aren't always big, beautiful things like this. As a matter of fact, crystals are everywhere. The salt you use to flavor your food, for example. It consists of little crystals of sodium chloride. You can see their shapes by looking at them through a magnifying glass. Little cubical crystals of sodium chloride. Snow. Here are some enlarged pictures of single snowflakes. Each is a single crystal of water. Here's a crystal I like especially well, probably because I made it myself. It's a crystal of alum. As a matter of fact, you can make a crystal just like it. I put some directions in the film notes in case you want to do it yourself. You buy the alum you need at a drugstore and grow the crystal in a mason jar. If you do this, I'm sure you'll be very much impressed by one thing. The crystal keeps growing, maybe for a week. It keeps getting bigger, but all the time, it has plain faces, meeting in sharp edges. You can see I haven't ground the faces on this crystal or polished them at all. This is just the way the beast grows. It almost seems as if you were getting something out of nothing, something with a shape all its own, which it decides all by itself throughout its career. In order to grow a single perfect crystal as big as this, you have to take pains and let everything happen slowly. But you can see what's actually happening by letting things happen a little bit faster and looking at the business under the microscope. I'm going to take a solution of alum, which is just itching to deposit crystals, and make a little pool of it on the microscope slide, and then add a few little crystals of alum to give the alum something to deposit on. And then get myself in focus and let her rip. There they are. You can actually see them grow if I turn now to a higher magnification. The little crystals keep pretty much the same shape as they grow, just getting bigger. Naturally, they all sit down on the microscope slide on one of their biggest faces. So you see the shape of the crystal depends mostly on what the crystal is made of, and not on its size, so long as it's free to grow in all directions. Now, crystals don't only grow out of solutions. They grow out of gases. Snowflakes, water crystals grow that way. And one of the most important places where crystals grow is out of melted materials when you cool them. Here I've got another powder you can get at the drugstore called Salal, which melts to convenient temperature. I'll put a little of it on a microscope slide. Then I'll carry it over here to the hot plate and melt it. And now let's go over here to the microscope. There's one growing, turning very slowly in the liquid as it grows, because it hasn't quite sat down on the slide yet. It seems almost to push those flat faces ahead through the part that's still melted. Of course, you know that the whole crystal isn't moving and shoving its front along. The liquid next to the face is becoming solid and adding itself to the face. But it's doing this in such a way that the stuff added on also forms a flat face, so the crystal keeps its shape while it grows. Now, I'll melt this back carefully on the hot plate so as to leave just a little rounded blob of crystal. That rounded blob will be a single crystal, but it won't have flat faces. And I want you to see what happens when this cools down again under the microscope. There it goes, growing the faces it wants to have, filling in the hollows and squaring off the rounded corners so that its boundaries are all flat again. Notice now what happens when two crystals bump into each other, so to speak. They don't push each other around, they just stop growing where they meet, because they've used up all the stuff to grow with there. So the boundary between two crystals isn't necessarily one of the natural faces on either of them. The boundary line just depends on how the crystals happen to come together. When the whole thing is finally frozen, you have a dense mass of crystals. Maybe no single one of them shows any of its natural faces, but the whole mass is made up of crystals just the same. Almost all rocks are made up this way. Granite's a good example. Here's a hunk of it. Let's take a close look at it. You can see grains of the different colored minerals which make up granite. Here's a grayish grain of quartz. Here's a grain of pink feldspar. And the little black flecks are grains of a kind of mica. And each of these grains will be a single crystal. Notice that the three things don't mix together in the solid. They crystallize out in separate grains. Before I get through, you'll begin to see why. When you came in, I was melting some bismuth in a crucible over here, and it's been cooling. And crystals ought to have formed on the sides of the crucible, so that when I pour off the part of the bismuth that's still melted, you can see them. Sometimes you can show up the crystals in a finished piece of metal by polishing the surface and then etching it carefully with something that will eat away the metal. Here's a cast brass door handle, which the manufacturer polished, and then over the years, the sweat on people's hands etched it, and now you can see the boundaries between some of the crystals which make up that door handle. In most pieces of metal, the crystals are much smaller than these crystals because they've been broken up when the metal was drawn or rolled or hammered into shape. But the metal is crystalline just the same. Well, so almost all solid things are made of crystals. In fact, if you ask a physicist these days to define a solid, he'll probably say a solid is a bit of matter that is crystalline. Of course, that doesn't seem to get him very far, because somebody is sure to ask, what do you mean by crystalline? But he's got an answer to that one. The answer comes in two parts. The first part says all matter is made of atoms. The second part says in crystalline matter, the atoms are arranged in regular order. I want to talk a little more about what he means by this and show you a little of the evidence for it. The idea is that the crystal is a pattern of atoms, a regularly repeated pattern of atoms, like the regularly repeated pattern of a wallpaper. If the atoms were flat and made a two-dimensional crystal, they might be taking up an orderly arrangement, like this arrangement of pennies on the table. In 3 dimensions, they might be making an arrangement like these bearing balls, closely packed together. Of course, these close-packed arrangements aren't the only arrangements the atoms might take. They're just simple examples of what I mean. Now, already, perhaps, you can see what these two ideas, the idea that a crystal is made of little units, atoms or molecules, all alike, and that those little units are arranged in the crystal in a regular array, you can see how those two ideas would explain what you've been looking at under the microscope. For instance, those alum crystals kept a symmetrical shape as they grew. Now suppose you had a two-dimensional crystal, like with a pattern of atoms like the arrangement of pennies. There are more atoms in solution all around it. But since the arrangement is symmetrical in the crystal, you expect pennies to add themselves on at the same rate here, and here, and here, and so on, because conditions are the same at all those places. The crystal will grow symmetrically and keep its shape, so long as nothing gets in the way and prevents more atoms from reaching the surfaces. Let me show you another kind of evidence for these two ideas. It's a kind of evidence which doesn't come from the process of growth. It comes from the properties of the finished crystal. This is the evidence of cleavage. If you've ever handled mica, you're acquainted with cleavage. The mica crystals you find in nature come apart easily in one direction and not in any other, so that you can split them into extremely thin, tough sheets. The mica acts as if it was made like a book, with a lot of leaves of tough paper. But if you actually try it, you'll get the feeling that there's no limit to the thinness of those leaves of paper. You'll feel that if you were skillful enough, you could split each leaf of the mica in 2, and then each of those in 2 again, and so on. It makes you guess that the atoms in the mica are arranged in great sheets, that the atoms are bonded together very tightly in the sheets, and the bonding forces between the sheets are very small. Just the arrangement of atoms in sheets like that is a kind of orderliness. There aren't many crystals that cleave as well as mica. Alum, for example, doesn't cleave at all, but a great many crystals do cleave amazingly well. Let me show you the cleavage in this crystal. It's a crystal of nickel sulfate hexahydrate. It cleaves parallel to this face. I'll put the thing down on a little plasticine to hold it in place. I'll take a single-edged razor blade and direct the blade parallel to the face and give the back of the blade a smart tap. She comes apart. And now look at that, as flat as you please. You may say, oh, you picked a special place in the crystal. But look, I can cleave it again, parallel to that same face, and get a thin plate out of the thing. So it isn't a special place in the crystal, it's a special direction in the crystal. Now maybe you'll say, oh, that isn't any special direction. You've got a sharp razor blade and you're cutting the thing apart with it. All right, if that's what you think, let me try the same stunt in a different direction. I
It
turn
is
my
so
razor blade in a different
1950s.
direction, and I whack it, and nothing much happens until I whack it a lot harder. And finally, of course, the thing busts, and there's no nice flat face. It's just broken apart like anything else.
This guy is awesome.
Now let me show you the cleavage in another crystal, a crystal of sodium nitrate. Here's a crystal that cleaves in 3 directions, not just one. I can cleave it here, like this, and I can cleave it here, like this, and here, like this. By the way, you can grow both these crystals, nickel sulfate and sodium nitrate, by recipes given in the film notes in case you want to play around with the stuff yourself. Sodium nitrate has a lot of interesting properties. It has most of the properties of the mineral calcite. When big crystals of calcite were first discovered about 300 years ago in a quarry in Iceland, the scientists of that day got hold of some, and their studies of the stuff made the first big start in our understanding of crystals. As I say, sodium nitrate and calcite have many properties in common. In particular, they both cleave the same way. When those earlier scientists saw the way calcite cleaves, they had the idea that maybe calcite was made of tiny building blocks, all alike and all having the shape of little cleavage blocks of calcite. You may be inclined to laugh at this and say that calcite, like all matter, must be made of atoms, and atoms don't look like building blocks. Okay, you're telling me. What do the atoms look like? Little hard round iron pellets? Don't let me fool you with those pennies and bearing balls I've been showing you. They just show where the atoms are, not what the atoms look like. For all I know, the atoms look like 4-leaf clovers. I want to emphasize that those early scientists produced both of the main ideas which go into the picture of a crystal that we have today. First, they were saying crystals have an ultimate fine structure, the building blocks. We would call them small groups of atoms instead of blocks, but the difference is really more a matter of words than of anything else. Second, they were saying that structure has a regular array. The blocks are stacked up in a regular order, and they keep stacking up in regular arrangement as the crystal grows. It turns out that you can think of any crystal, not only crystals which show cleavage, but any crystal, as made of little blocks stacked up in regular array without overlapping on top of one another and side by side, if you choose the right shape of block. In the case of alum, the right shape of block is a cube. And you can think of the alum crystal as made of little cubes, all stacked up on top of one another without overlapping this way.
Illuminati confirmed.
Notice
Pyramid.
that I've made the main faces on the model of the alum crystal by stepping back the cubes as I pile them up. At first you might think that would mean that the face would be pretty rough. But you've got to remember that these little cubes are really only a few atoms wide. Their sides are only about 1/10,000,000th of a centimeter long, and you wouldn't feel that roughness or even see it under the microscope. One of the things that gave early support to the building block idea was the fact that all crystals of the same stuff have the same angles between corresponding faces. The crystals might be very different in size. They might have grown at different rates on different faces so that they have different overall shapes, like these 2 alum crystals. Nevertheless, the angles between corresponding faces of all crystals are the same, so long as the crystals are made of the same material. It all suggests very strongly that each material forms its own building block, which gets repeated again and again as the crystal grows. Most crystals can't be made out of cubic building blocks, as alum can. Their building blocks don't have the same length in the different directions. For example, here is the arrangement of atoms in the cubic building block for iron. It's fairly simple. Now look at this model of the building block for garnet. It represents an elaborate grouping of 160 atoms. But this study isn't easy. Don't get the idea you can turn on the x-rays and out drops the answer. It's a very specialized kind of study. But once we know what arrangements atoms take in crystals, we can begin to ask why they take those arrangements. We're really only just beginning to get that kind of
Frequency,
Now,
vibration.
turn back for a moment to the microscope and remind yourself of what is happening
All
while a
of
crystal
that.
grows.
Yup.
Atoms are constantly arriving at the surfaces and adding themselves onto those surfaces in an orderly way. And
It
they're
makes
doing
more
this at an
sense
amazing rate of speed.
in a
The crystals you're
frequency
looking at are growing
vibration
fairly fast.
sense,
Suppose
actually.
a crystal grew at the rate of only a couple of millimeters
Yeah, you
a
have
day, which is fairly slow.
incorporate
You
the
can
two
calculate
together, and
that about
that's
1,000
the missing
layers
piece
of
from the
molecules
video.
would have to be laid down per second on the surface of that crystal. And all the molecules
Agreed.
have to be laid down in the right sort of order. I want to borrow a trick from Sir Lawrence Bragg to give you just a rough idea of some of the things that we think must go on as a crystal grows. Sir Lawrence blows soap bubbles. He blows them in a pan of soapy
Platonic
water.
solids.
Tiny bubbles,
Yep.
which rise to the surface and collect in rafts.
No, that's
The
exactly
bubbles
what they
behave
are,
a little
yes.
like atoms,
Yep.
because when they're floating on the water, they attract one another a little. And when they touch, they stick to one another quite strongly, as
Our
atoms do.
elements grow in platonic
But,
solids.
again, like the
It's
atoms,
their
they
nature.
have a squashy sort of size, so that they take up space.
So,
Watch how the bubbles
covalent
collect together
bonding,
into an orderly arrangement.
frequency.
It's the same as the arrangement of pennies I showed
Yes.
you, the so-called close-packed
Perfect.
arrangement. Notice that the rafts are made of large parts. All of the parts have the same sort of order, but the orderliness of the parts is turned in different directions, so that there are grain boundaries between the parts. This is like a solid made of lots of crystals which started growing in different places and finally joined. It's like the Ceylal after it is all solidified.
And I would suggest probably, I just want to pause here for a moment, since we were saying that when you get into chemistry and include Avogadro's number, and since that works, that was one of my questions in dealing with the periodic table of the elements and trying to figure out how this would work in a harmonic frequency sort of way. I suspect that much like Fibonacci sequence, that what we would find is that the Avogadro number constant would be a ratio between these frequencies such that they harmonize, so that we could do we could come up with chemical compounds in advance by doing that, instead of using the idea of electrons and sp and df suborbitals, that you could do this with frequencies. So yeah, anyway.
Okay, I love you. Pause him a minute. I want to take you on that idea.
Okay. Okay.
Okay, if you look up into the term gamut, G-A-M-U-T,
Yep.
you'll find historically it's going to be a musical scale, or it's going to start with a musical scale at the very lowest frequency man can hear, which is called bass G, and it follows a very, very specific scale, and it follows a very specific, you're talking about the Fibonacci in this. It will take that and run the gamut. That's your gamut. That's your gamut is starting there, but it's made up of gamma ut. Your base
Gamma,
word is
right.
gamma,
Yep.
and ut. These are going to take you into all of the scales of the frequency ranges and give you the scales of everything to do what you're talking
God,
about.
that's
It will give you your
perfect.
math ratio. I'm
You're blowing my
convinced.
fucking mind, man. This is awesome. This is yes.
Yeah, I am convinced that the G on the Mason board
Yep.
is gamut, because the two pillars are your magnetic pillars. That if you place
Yes.
the pillars, the third pillar creates, but your gamut, until you add your frequency, until you add it, it tells you exactly a starting point and tells you where to start and
The
where to
intervals
end.
between them. Yes.
And the intervals and the mathematic intervals of frequency. People,
Oh.
you run the gamut. So
Yes.
it's the piece in the puzzle. It's very, very specific, and
Oh,
it has
God,
all of
yes.
your math and frequency. So I'll shut up.
Absolutely. No, this is this is awesome. This is the kind of shit that I love. See, I told you I wasn't really in the mood this morning, but this is every bit worth.
Me either, but when we get on it, that's what I said is Rose inspired me to push it through the way that Rose pushes through everything she does.
And check this out. Here's the video over here. Matter waves on wave theory, because that's what I'm totally into, is
Or
wave
that
theory.
brass door handle.
Okay, sorry.
When you
Okay.
think of
Yeah,
how
we-
fast the atoms have to get into order,
We got like
much
4
faster
minutes
than
left.
this, the more astounding their achievement seems to be. But this will give you some little idea of what a hustle and bustle must really have to go on an atomic scale. Sometimes when the molecules are very big and have an irregular shape, they're too sluggish to get themselves arranged into order. Then they congeal into a glass. A glass is very much like a liquid, but it's like a liquid in which the molecules are no longer able to move past each other. It has patches of order in the midst of disorder. The disorder is frozen in place, so to speak, and can't get itself rearranged into order. Liquids and glasses are pretty disorderly arrangements of molecules, and gases are the most disorderly arrangements of all. The only order in gases is the arrangement of atoms grouped in each molecule of the gas. Later in this course, you'll learn more about gases. But already,
which, by the way, explains why you cannot have gas giants or the sun being a huge ball of hydrogen within 10 to the minus 17 torr vacuum. So just pointing that out.
I love you. You're right.
Just want to point that out.
Freddie,
I love
you
you
can
too.
see why
This
gases
is awesome.
are so very much alike in a great many ways, whereas there are so many different kinds of solids. The only way gases can differ is in the kinds of molecules they are made of. But solids can differ also in the kind of orderliness which those molecules take up in the crystals which comprise the solid. I can show you this selectiveness actually happening in some of the materials you've already looked at. I'll melt some salal on the hot plate over here. There. And bring it over to the microscope and let it cool down so that it wants to crystallize. Then I'll seed the salal with a tiny crystal of alum. Nothing happens. No salal will crystallize on it. Now, I'll seed the melt with a few little crystals of salal. And you can see the salal crystals grow, leaving the alum crystal unaffected. The orderliness of alum is not the right kind of orderliness for salal, and the salal simply waits until the right kind of orderliness is presented to it. And I think now you can see what I promised you would see about granite. Why it is that the three different ingredients, quartz, feldspar, and mica, form three separate kinds of crystals in the granite and don't form just a single crystal in which the molecules of quartz, feldspar, and mica all take part together. It's because those three kinds of molecules normally form crystals with three different kinds of order. When the three kinds of molecules are all together, they can't find a kind of order which is common to all three of them. So they crystallize out separately, each in its preferred way. You know, after 20 years of growing crystals, I still find the whole business nearly miraculous. You go to the microscope to watch it,
That's right,
and it
Bubba.
happens again. And you know that the atoms are at work, busily, almost unerringly, constructing something. Something regular, something orderly, constructing something which, from an atom's point of view, is simply enormous.
Outstanding. I love it. Oh,
Now,
man.
taking that a little bit further at the end of the video, there have been a lot of studies done where our elements grow at different rates depending on planetary and star alignment, day, night, sun, moon, stars.
Interesting.
So, for instance, Mercury grows at a faster rate and grows better when Mercury happens to be present. There's more to this than we understand, the way that the vibrations are seeking through. But now I'll shut up.
No, I need a lab now, right?
I miss having a full lab so bad. The stones have so many properties that he didn't get into,
Yep.
and the properties that they possess can provide so many answers. I mean, this is the stuff that's real and the stuff that they're not teaching us, but all of the answers, when looking to the answers of how this place works,
Well, so
they're
here's,
all there.
So here's the thing. So when I was speaking previously about iridium 192 and its radioisotopic halo that's apparent in granite, one of the things about it is when I was researching that and looking into the study is one of the things that it indicated is a quadrupolar field, right? And
Oh my God.
and that's
Okay, that's magical right there.
exactly. And so
Quadrupolar fields, they create their own magnetic trapping and stuff around them. That's okay. Never
and
mind.
that's
Go.
my working hypothesis for the realm that we're in is it most closely comports to a quadrupolar toroidal field. That's what it looks like to me.
Okay. It is. I'm going to have to go up and. You haven't seen any of my map work, have you?
No.
Oh God.
Oh dear.
Okay.
We're in
Oh,
so much
dear.
trouble now.
We are in so much trouble now.
All
We
right.
are. Okay, so you understand the magic of a quadrupole,
Yes.
dipoles, and all of that.
Yes. Uh-huh.
Oh, okay. You are my huckleberry.
You know it. This is my area right here. This is
Uh,
we get into nerd speak, but
uh,
this is where I go crazy.
no, no, no. This is my area. When we get in the nerd speak, you're articulate. But okay, can the girl figure out how to share a screen? And let me get something up.
Okay, so what I have to do then is I'll have to put it. Let's see. Let me find
Oh,
this.
you have. I'm not on Zoom. You have to do this yourself.
Yeah, I would have to do. If you could, I don't know if you had something you could send me.
No, no, no. I can. I can put it in the chat. I can give you some pics in the chat. No problem
Okay.
at all. Give me
Yep.
1 second.
This for those of you in the chat and for those of you who are following along, I'm sorry, I'm just a super nerd. This stuff is what floats my boat right here, guys. This is when we get into the fascinating. When this guy said, "Yes, it's like magic." I'm like, "You're right," or a miracle. That's what he said, right? It's miraculous. I'm like, absolutely right. These things are fascinating to me, and when he's talking about the properties. I'm like, when you combine this with the material properties of water, which I've been studying for more than 2 years now in depth, it's mind blowing. If I were to say it's deep. Yeah, that's funny. But yeah, it is spectacular. Okay, so let's see. How do I grab that?
I think I hit a screen share. What screen do you have up?
Yeah, I see.
What is?
I see a combination. I see. Yeah, I've got your
Okay.
desktop, and then I see these. You're looking at pictures in your file folder.
Okay. Do you have a picture up right now that shows a quadrupole on it, or no? A giant picture.
Yes. Okay. So let me slide this up here. And then
Do
let
you
me
have it now?
That. Oh, that's not the right one. Let's see here. Can I do that? Nope. That. Oh, it's going to show this one. I would have to.
I can move the screen on it. I can tell me
I'll
where you want it,
change this to.
because it can go either or.
Oh, hang on a second. Let me do this. Let me do this. Hey, bear with me, guys. I gotta just add this. Let's see.
I don't know about the rest of the chat, but this will be worth it for you.
Okay. Okay, and then I want display 3. Okay. Okay. So now we should be good. Thanks for bearing with me, guys. Hope we didn't lose too many people there. Oh God, yeah. Oh.
Okay, this.
Okay. All right.
Okay, he recognizes what he's seeing, and I love him for it. What you're looking is you're looking at a magnetic declination or a magnetic
Yep.
map being projected out in AE, and we'll take that a little bit further in a second. But what you'll notice is that you'll notice that there is a dipole right where. Do you see
Right
my
there.
cursor?
Yep.
Yeah.
Yep.
A quadrupole
Quadrupole,
right
yeah.
here, and of course you have off of the map right here. What are you going to have? You're going to have
Another dipole.
dipole
Yep.
to
You
connect
have to,
your lines.
'cause you have to. Right.
You have to because you have no chot in it, right?
Yeah.
Okay.
Yeah. But it have to be there. Yes.
Okay, so a quadrupole can be created by different ways, as you know. You could take a positive, you could take 4 magnets pillars, place them upright, and have positive, negative, and 4 pillars standing. Do you get that visual?
Yep. But so
Okay,
if you
could
flip this over, go. I'm sorry. Go ahead. Yep.
You can also create it by laying a magnet across, 2 magnets going across, positive, negative, positive, negative. Okay, but and you can also create it by running an anti in this configuration. You can run coils and do it in an anti-Helmholtz configuration.
Right. Yep.
But you're gonna love this. The other way you can do it that they don't tell you that we've done in Ferrocell is you can. Are you ready?
Yep.
Take 2 dipoles, and if you put 2 dipoles and place them correctly, a quadrupole appears in the center.
Appears in the middle.
It
Of course it does.
It creates the counter space all
Yes.
by itself.
Well, yes,
Now-
and this is why I was picturing this. If you look at this as a toroidal field, right, and in a 3-dimensional space, then what you would have here on the Earth plane, right, well, there would be an accretion disk, right? So you'd have your dipolar accretion or dielectric accretion disk right there in the middle.
Yes.
That's where we're at.
That's where we're at. Now, if you take we'll do that too on the things too. If you take the map, let me show you what I did to get to this first because it's too confusing to put out at once. If you take, here, you know how the WGS 84 is a flat and ellipsoid data set?
Yep.
So if you take a flat and ellipsoid, hold on. If you take a flat and ellipsoid, you see that?
Yep.
And if you draw all the longitude, latitude lines on it, and if you draw the continents on it, which I did do, it just got, I'm not going to show you my messy rendition. It turned out ugly with the orange juice, right?
Right.
But then if you think about it, if you peel it from the bottom where Antarctica is and don't peel through any of the continents or anything because you can't break it, and don't peel through any of the trade routes because I marked where they ship things.
Right.
And then pull the orange out and stretch your orange peel. So you follow what I say, because if you open it up that way, you're going to open up everything and keep it in perfect time.
Oh, yeah.
As opposed to moving the continents around, you have to keep it in perfect time.
Yep.
So if you do that, oops, cancel. I don't want to. How do I make this big? I thought.
I can kind of blow it up a little bit. So
maybe
I can zoom in.
Well,
on it.
I think there it is. Okay.
Yep.
Okay. If you open it up, what I did was I took two cutouts. I'm really bad at computer art, especially, and other art in general. The other thing I should tell you about that pattern with the quadruple in the middle is I don't have it zoomed out, but what it does is it creates a magnetic boundary that looks like this.
Sure. Okay. Yep.
And it creates a very sharp magnetic. If you've looked at things under Ferrocell,
hexagonal.
It is hexagonal.
Right,
it's like they drew the lines and so if you zoom it out, you get that hexagonal.
Gotcha.
So you would have the North Pole in the center. You have I have it walking one of your pillars here, one of your pillars here.
There.
This is off of the map. When you travel the WGS 84, your trade routes and everything, really, if you were to heal this like I did with the orange and pull it out, all of these lines connect.
Oh, okay, yeah. That would
In
make
perfect
sense.
time. In other words, think about it. You keep all of your longitude and your latitude
accurate and in scale with each other.
In scale with eich other and accurate. And everything contiguous. So when you're flying and you look at the way that your flights go.
Oh, Bob, you're funny. Baba's funny. There's the tortoise. I got you.
There is your tortoise. There is. Trust. When I peeled the oranges, I wanted to get a lotus. I wanted to get a platonic solid. I wanted to get a flower. I got a turtle. No matter how many times I tried to do it.
But the hexagonal shape makes sense. I mean, that's a platonic solid.
That's a platonic solid. So frequency-wise on it, right now, I believe that we're closed off on this line right here. I almost feel like it's a boundary. This is your South Atlantic anomaly here that ships and things can't go.
Yep.
In order to carry this pattern, you need a landmass here. Your landmasses and your magnetics are
so it has to be. There has to be one there.
There has to be one there because you would have to grow magnetite, which we have a ton of right here.
Right.
You're going to have landmasses. You have to have landmasses
in each of the corners, right?
Each of the corners and on the poles.
The outer lands.
Your poles are your big land masses. I believe your ice walls is where the sun doesn't reach and the ice freezes and creates a wall where it freezes out around it. But you have to have actual land masses, not walls, in order to carry your magnetic pattern.
There has to be something, physical with, again, a mineral of some sort, and crystal and mineral,
And to carry the pattern.
Exactly,
And we know what it is in nature. No, and in nature, magnets are what it is. Magnetite is very, very abundant. And when magnetite gets columnized or hit with electricity, that's how you get lodestones.
Yeah, lodestone, sure,
So lodestone is nothing but one of our most abundant minerals on this realm hit with lightning or hit with electricity.
And there's a lot of stories about the Mount Meru.
Yes, Mount Meru is probably right in the center.
Yeah.
You're going to hold in there. You're going to have land masses too. You have an actual vortex that's going up and down levels. Would you like to see how it extrapolates up and down?
Yes, that's what, because I'm picturing it already, right? And going, and this comports well with the Yggdrasil, the world tree, right? So
That's exactly okay. When you take your
oh, there. Oh, look at that.
okay, okay.
Well, I've seen that before.
If you take, you can do this. You can do this, Baldini. If you take the two pillars and put one here
Yeah.
and one here,
Yeah.
it will pop out your tree of life.
Yep.
You'll have your tree of knowledge, evil, your tree of knowledge, good, your tree of life down the center. I don't have your other pillars, your pillars that draw it. So you know how your Sephiroth is sometimes drawn all the way out, like spread?
Yes. Uh-huh.
That's showing a view of it where you're seeing the two pillars. If you twist it, I don't have the pillars attached to it, but if you picture doing this in 3D, what would happen when you look at it is some pictures you're seeing of it is at one angle that you see the pillars. When you put the pillars at a straight angle, they become in line with the tree of life, so they disappear. So that's the narrow view. The narrow view has the pillars, so they disappear in 3D. Do you understand? If you had
Yes.
the pillars right down the middle and you turned it, you would have the narrow view. But if you leave them on, you would have the wide view.
Oh my God.
And leave off of the set. So your realms we live on this realm here. Like you put your earth here where it comes together, and this is where when you put the copper and that around the pillars, around the magnets, it separates the electricity from the magnetism and shoots everything down through the middle, creating your tree of life going up and down through the realms. This
just
is
showing
how
this real quickly. I'm just kind of showing
Yeah.
this to folks that the tree of life is pictured here. That's what we're talking about right now. It's that guy. Yeah. Okay. So yeah, sure.
we'll go back and let you go back to this would be Sheol, hell, the underworld right here. Your harmonics and your discordance and your heat. Think of this as red going, orange going to red, purple in your colors against source and going up. Here's your greens going into your blues. Source is purple. I have it all written down as far as your colors hitting each one of them. These are magnetic ground spots. These are places that you're going to have it. But if you look up, this would be your firmament, which they show empty. That's your mirrors. Your miroscope or your hologram emitter, if you haven't followed any of that work. Are you familiar with that at all?
Just slightly. I mean, I understand though the firmament, probably a crystalline structure, right, of some kind, and but
no, it's a firmament. If the firmament was a vault of looking glass,
right,
it would function as a natural hologram emitter, like a miroscope. Yes.
Yes. Okay.
So,
no, I'm with you, and it's required. Yeah. It's a requirement for rainbows, right? You have to have you have to have a reflection, another point source of a reflection, right? Yep.
It's even more than that, but we can talk that there. So your firmament,
that's basic, overly simplified.
So your heaven, your heaven is here,
yep.
But your high heaven, this is the firmament, the silver river you cross, the vaulted looking glass that you cross to get into heaven, to get to source up here.
So
it's a physical realm.
Yes.
It's a very physical. In other words, we have physical, and if you look at it and do the outline on it, you'll see it's very egg-shaped.
Well, the world egg, of course. I mean, why not? I mean, yeah.
But your realms would be like in physical. We're on this physical realm.
Yes.
And if you go underneath, you go to hell where it gets discordant, the earthquakes. You can see by the magnetics how discordant it would get in this area. This is your area of heaven, the firmament, where you cross over to get to south. This is where you would ascend to get to heaven up here.
Yep. But basically, there's a boundary for all of it. Yep, the boundary line.
I believe that when they talk about in song, hi Karen.
Hi Karen B.
I'm doing the hard way to get through the pictures and maybe not most efficient, but I believe when they talk about in song, and people talk about the island that the stars are going to get away.
Mm-hmm.
In song, they'll say things like in the song Man of the Moon, here's a truck stop instead of St. Peter. Here's a little, offering. They're telling us that they have a way to break outside the grid that's not through St. Peter, not through the firmament. I think they're selling their soul to a low frequency that no matter what, I think that you lock yourself into a low frequency, but I believe that there's a physical place that they can go, they know about, that we're on the Flammarion, where they show the break in the dome.
Mm-hmm. Yep. And that's what we would see. Well, the ancients call it the crack in the sky, right?
Right.
The Magellanic Cloud. Yeah.
That I think is the Milky Way I think might be the crack in the sky.
The crack
that
in the
we
sky.
did.
Yep.
But I do think the Flammarion. I have to have the Flammarion in favorites. Why wouldn't I? Aha.
Oh yeah, that image. Yes. Yeah. Okay. Yep.
Okay. The Flammarion, where you see
he's sticking his head out. Yep. To see
he's
beyond
sticking
it.
his head out. You see, here's the crack in the dome, and that I think that's where that land is. That's green. That pole that I have that's off of the map, battery-wise, would be a hot piece of land, where our other one would be your cold. I think there's a big-ass piece of land that's got warmth. That again, they have a way breaking out. But the secret is if you break out the source in a low density, you've locked yourself. You've sold yourself to the devil. You've locked yourself.
Yeah, pretty much. Yeah. No, I'm absolutely down with that, and changing the frequency. And yeah, okay.
I see the sun and the moon in the firmament mirroring down
into the firmament. Right. So the source, the source is outside it.
Source is in the firmament, and they're actually.
Okay,
it shows you here. It shows you.
Exactly the way I had pictured the sun, right, is being outside the firmament, but what we see is a representation of it inside. It's a
I think it's
transformer of some kind, right? Yeah.
Are you familiar with those little hologram emitters that you drop something in a dish?
Yep.
That is a vault of looking glass, by the way. Can you imagine how powerful that vault of looking glass would be if it was
at that scale?
No, at that scale, and if it was not plastic, scratched plastic, but if it was grown out of the noble metals, platinum, iridium, ruthenium, these things that make a perfect mirror finish, if you grew through frequency, the vault, can you imagine the power of colonization? That platinum, iridium, think about what it does in technology, and see how well this mirrorscope, I don't know if you know this, but it will, if you put a piece of ice cube in the mirrorscope, the hologram will be cold.
Really?
Yeah, it transfers. A natural hologram doesn't transfer the optical waves, it transfers the gamut, it transfers the
whole thing.
So if you hit a hologram, this type of hologram with a light,
so its focal point would be so its focal point would be, again, for the sun, very hot, and for the moon, that whatever that energy is, that's a colder, putrefying energy. And they're polar from each other. Absolutely.
So in the firmament, it's the black sun. It's not lit up. It ignites when it comes into our existence. It's the black sun.
The black sun.
Rahu in the firmament. Mm-hmm. And it's K2, the moon, in the firmament.
Right. And that's what causes the eclipses, right?
Yes, they cause the eclipse because there is a polarity. When you cross polarity.
And they get a node, but they'll cancel each other out. They
cancel each other out. It's like taking sunglasses and turning them sideways.
It's polarized, sure. Or the same with audio signal. If you put them in exactly inverted, it just cancels each other out, right? You get a node.
What's interesting about Polaroid filters is if you add more filters into the mix, like
it's additive, right?
No, it's not additive. You have to. Can I do a video for you?
Yeah.
It's amazing.
Yeah.
It's amazing. Okay. Do you want me to drop it into your chat?
Yeah, you can drop it in my chat. That's perfect.
Okay.
Give me just a second. Let me.
Give me just a second. I have to find it, and this is just the first few minutes of it. This is going to blow your mind.
Yeah, it's already blowing my mind. I'm like, I'm not going to sleep for days now, right?
Really? You're a geek kindred. You are geek kindred.
Yeah, I'm going to be like, oh my God, I got to study this sort of shit.
Okay, this one you're going to like a lot.
You're putting, you're putting, you're giving me, so these are like pieces of the puzzle, right? So it's like adding these pieces. I'm like, because all right.
All right. So hold on one second.
Yep.
And
standing by.
As soon as I find the window that I have the chat, I have the video. As soon as I close all of my pictures and find where I am with you in chat, here you are. Paste. Go.
There we go. I got it. I got that. Bring up this.
I probably won't.
If you have polarized sunglasses, you have a quantum measurement device.
Each of these pieces of glass is what's called a polarizing filter, which means when a photon of light reaches the glass, it either passes through or it doesn't. and whether or not it passes through is effectively a measurement of whether or not that photon is polarized in a given direction.
Try this. Find yourself several sets of polarized sunglasses.
And by the way, photons are nonsense. It's a wave. But anyway.
Wait, yeah, it's a privation. It's a wave theory. Yeah,
Yeah, exactly. Okay,
there are no particles of light.
no,
Yes.
yeah, it's not a particle. It's a wave, and there has to be an ether. Oh,
Sunglasses or old
You're right.
photographic filters. Look through one set of sunglasses at some
It's
light
only
source, like a
logical.
lamp, then hold a second polarizing filter between you and the light. As you rotate that second filter, the lamp will look lighter and darker. It should look darkest when
Bob
the
says
second
the
filter
video's
is
not
oriented
showing.
90 degrees off from the first. What you're observing
he said the video's not showing. Oh, sorry. Hang on. That's me. Okay, so sorry, my bad. And okay.
filters. Look through one set of sunglasses at some light source, like a lamp, then hold a second polarizing filter between you and the light. As you rotate that second filter, the lamp will look lighter and darker. It should look darkest when the second filter is oriented 90 degrees off from the first. What you're observing is that the photons with polarization that allows them to pass through a filter along one axis have a much lower probability of passing through a second filter along a perpendicular axis. In principle, zero probability.
But here's where things get quantumly bizarre.
Yeah, this
all
is the
these
fun
filters
part.
do is remove light. They filter
Get
it out.
thinner.
But if you take a third filter and orient it 45 degrees off from that first one, and then you put it in between the two, the lamp actually looks brighter. This is not the middle filter generating more light. Somehow, introducing another filter actually lets more light through. With perfect filters, if you keep adding more and more in between at in-between angles, this trend actually continues. More light.
This feels super weird, but it's not just weird that more light comes through. When you dig in quantitatively to exactly how much more light comes through, the numbers don't just seem too high, they seem impossibly high. And when we tug at this thread, it leads to an experiment a little more sophisticated than this sunglasses demo that forces us to question some very basic assumptions we have about the way the universe works. Like that the results of experiments describe properties of the thing you're experimenting on, and that cause and effect don't travel faster than the speed of light. These will come into question.
Where we're headed is Bell's theorem, one of the most thought-provoking discoveries in modern physics. And to appreciate it,
pull
I
up
really
whenever
do
you
think
want
it's worth
to.
understanding a little of the math that we use to represent quantum states.
I'm sorry. Do you say you're done?
I think we can go forward.
Okay. Oh, go forward in the video, you mean?
No, stop the
just,
video.
yeah, okay, yeah, okay. I'm with you. All right, so that. Ding. And do you have anything else to show, or?
No, I want you guys to stop and think about what he said right there. That when you added, oops, I have double audio now. I snuck into the show and listened to back way to hear what was going on, and it got me confused. Okay, I should be okay now. But I want you to think what he's saying. In other words, you filtered out 100% of the light, and you added another area of polarity, and you added light back in. That's like taking a colander and pouring water in it, only having half of it come through, and putting another colander and having
and you
more
get more.
water.
Yeah.
And you get more. It does not work. Like the mirroscope does not produce a digital hologram. It produces all of the waves of the hologram. The Polaroid filters do not work the same in digital world as they do in analog.
But they're working with the idea that those are photons, and that wouldn't work. But if you're working with wave theory would say that if you put them, they would you get additive wave synthesis, right? So they would
Correct.
It would increase your amplitude.
Right.
So I mean, the reason they're flummoxed is because they're looking at it all wrong, backwards, right? They're thinking of it as a particle.
Exactly.
And if it's not a particle, it's a wave. And so when you go into wave theory, as soon as you go into wave theory, it makes total sense, because now you're doing it increases the amplitude when you put them in the proper phase. And the more you add, right, it would just continue to be an additive wave synthesis. Yeah, absolutely.
That's exactly right, and that's why they have a paradox there. That's not really there at all.
It's not there. Yeah, exactly.
It's not there, and it's why they can't model something like this on a computer, because you can't model it to do the filters in each angle and the different variables. They can observe that it really happens, but it doesn't make sense to them that it happens.
Sure, because they're on the wrong model entirely, right?
Exactly. So if you add those, if you think that the polarity that we generate, that everything has a polarity and generates a field. So if you add the polarity to the mix, it's called the Faraday effect. But if you add that to the mix, your eclipses are really easy to see, even where they get brighter and bright red in the middle and get shadowy at the edge. If you think about what he did with those filters and how you saw them,
Oh, yeah, absolutely. Because you go into the infrareds, you'd go into the infrared spectrum before as the polarity is changing. Yes, because it's not an instant switch; it's a gradual. It begins to do additive and subtractive, additive and destructive waveform synthesis. Yes.
So the shadow on the moon has nothing to do with a reflection or a shadow on anything. All it is the size of the magnetic field it's crossing through.
Yep. Okay. Yes. I mean, it's all it's all within the electromagnetic spectrum. Absolutely.
Right. Exactly. Okay.
Okay.
I thought you would like that. You didn't like it as much as I thought you would, but you might know polarity, better on it. You get it so well, so that's perfect.
It just makes perfect sense. Like, it does. It's less mind blowing probably because I'm like, because I get wave theory. So I'm like, well, totally, yes. Now these pieces of the puzzle are all dropping in together. And, again, for me, as I look at, I've been looking at the periodic table of elements for a while and going, it's not as described. And, I came back to the idea of frequency and vibration, right? And it has to be that way. And it's basically, it's a kind of combined with electromagnetism. And that's the way it all works out. Like everything is electromagnetism. It's part of that same field theory. Yes.
I take it instead of where they're calling it atoms and little particles or little pieces, I see it where it breaks down to vibration frequency.
Exactly.
It's charges. And it's interactive, like you explained. Everything interacts with everything else.
Yes. No, exactly. And then it comes, that's why I need, again, a laboratory so I can start looking at more at the frequencies, because then I can go back to the work of Royal Rife. And his
genius,
his stuff. I could probably look more closely than at Tesla and combine that with Maxwell and Planck. Then we're you and Bob want to come over for a weekend? We'll figure it out. We'll get Zach over.
And you are in the Carolinas, right? You are
I'm in Seattle. So,
you're in Seattle.
Yeah, I would have to come out and join the commune. See, now I'm on the West Coast. Yeah. Exactly. I have to come out to that new commune. Tell me when it's got a name, but I'm all over that because we'd spend a weekend or two on this, and we'll get it all figured out. No problem. This has been bloody amazing. I love you, Cami. This is awesome.
I'm ready to quit too. I think this has been so fun for almost canceling the show. We've had fun with it.
Absolutely.
So thank you everybody for putting up with this. I want to talk to more, sir.
Yeah, we'll definitely do that. And then I wanted to. I saw somebody said they wanted more of this. You are fucking awesome. This is a book that's a coloring book, an adult coloring book that somebody just randomly bought for me and sent to my PO box. So I really appreciate that. And my wife said, I'll color the shit out of that because I got her a couple of adult coloring books and all these pens. She's got metallics and all kinds of stuff. So and each one is, a little bit of a naughty, inspirational quote, if you will. So love that. All right. Well, Cami, thank you so much for spending the time with me this morning. And I'm so glad you did. And I know that, again, we were both kind of like, and I feel very badly that you had to suffer through really not feeling well today. So thank you again for spending the time and enlightening me, because, again, I won't sleep for days now. Again, thanks everybody for joining us this morning. I'm so glad you did. If you're into it, again, tomorrow. So here's the thing. Wayne and I had started a new series called Sola Scriptura, where we're looking at kind of an exegesis of scriptures. Wayne joins every other Sunday, so as a result, he is unable to join us this week. He was with us last week, and then we also changed from the morning to the evening. However, just to kind of keep things consistent, I'm going to continue doing it every Sunday, but I'm also going to do a morning and an evening. But the morning one, I'm going to just change it a little bit. We talked a bit about the book of Proverbs and kind of gave you the Proverbs challenge. So I'm just going to kind of do that in the morning. And so we'll do that 7 o'clock in the morning Pacific, 10 a.m. Eastern. We'll just call that Ancient Wisdom for a Modern World. We'll just do a little brief bit there, and I got some questions to answer for or people who ask questions, so I'll do my best to answer those. And then we'll do a 0.5 episode tomorrow evening at 5 p.m. Pacific. That's 8 p.m. East Coast time. If you want to get in touch with me, you can reach me at unintended.consequences3@gmail.com. And you can also reach me at P.O. Box 2248, Linwood, Lynnwood, Washington 98036. If you want to contribute to the cause, I'm probably about a third of the way into paying off the computer, and I got some more software to buy and stuff. But not trying to twist your arm. But if you want to get in on that, you can PayPal.me/Great Baldini. There's other ways to do that as well, but that's probably the easiest one. You're right, guys. We do have the coolest kids hanging out in this group, and I love you all. Everybody I've come to know, I've just been thrilled. I got to meet Ted Summer in person. I got to meet Ceiling Fan Man, as well as Russell from, I call him Bunny, Russell Babbitt, Russell's rabbit there, Bunny, from as far as I can tell. So they know what I look like, but beyond that, no. Everybody, the Sue Finelli, Dawn and Joe, Winston, Nemo, Red Fox, all you guys are just amazing human beings, and I'm so terribly glad that we started this. All came from the Awakening Project, which I'm still working on, moving closer to phase 2, and I'll have actually some numbers and charts and facts and figures to show you as well from the phase 1 information, so that'll be exciting. That's coming up in the next few weeks, but first trying to get everything worked out with the new computer here and get it all put together. So with that, again, thanks very much, guys. I'll leave you with some music on the way out, as per usual, kind of running out of some tunes, but we'll make it all work for you. And so with that, thanks a lot, guys, and again, I hope to see you tomorrow morning, 7 a.m. Pacific time, for Ancient Wisdom for a Modern World, tomorrow night at 5 p.m. For a 0.5 episode of Sola Scriptura. Oh dear, really? You're not gonna do that for me? Wait, it's struggling. It's gonna try, I think. Maybe not. It's trying. Let's see. We'll try it again. Get a little music going here, and we'll try that. There we go. All right. Thanks, guys. And again, we'll see you next week for sure. And if you want to join me for those other episodes, we can do that. Thanks to Cami. Thanks for everybody joining us. And we'll see you again next week. Bye-bye.
Visible streets pull me to your side, marking a pathway where solace resides. But solace is tempered with a burden of proof, that hearts are sincere and lips speak the truth. Your innocence is an endearing quality, but also serves as a warning to me. And never take more than you give. Never break what you cannot replace. Things easily shattered are best left untouched. So God help me learn not to love you too much. A twist of fate or a twist of the night, both means to an end in an unfulfilled life. You want and you need, you beg and receive. Your gifts in return are few in between. Your promises empty, apologies old. Your words are impassioned, but your heart grows cold when you take more than you give. When you break what you cannot replace. Things easily shattered are best left untouched. So God help me learn not to love you too much. the hunger of the soul this time. Never take more than you give.